All right, let's dive into a rapid-fire revision on geometry and measures for your GCSE higher tier exam. Think of this as building your essential toolkit, getting you ready to tackle any question the examiners can throw at you.
So, here's the game plan. We've got 5 key sections. We'll kick things off with the absolute basics, lines and angles, before moving on to how you prove shapes are identical. Then we'll get hands-on with constructions, play around with transformations, and finish up with the heavy hitters, circles and 3D shapes. Let's get that toolkit built. Right, let's get started with the blueprints for everything else. Lines, angles, and shapes. Honestly, if you can get these fundamental rules locked down, you're going to find the more complex problems so much easier.
First up, the core angle rules. Your first job in any angle problem is to hunt for parallel lines. If you can spot a Z shape, you know the alternate angles are equal. See an F shape? The corresponding angles are equal. These 5 rules, they are your bread and butter for picking up easy marks on those angle-chasing questions.
Now, let's see how those rules work in actual shapes. You know, angles in a triangle add up to 81, and in a quadrilateral, it's 360. But here's a pro tip for your exam. Remember the isosceles triangle. It's not just about 2 equal sides, it's the 2 base angles being equal that examiners absolutely love to hide in plain sight.
Okay, time for our second tool, proving with congruence. You see, in geometry, just saying 2 shapes look the same gets you 0 marks. You have to prove it. So, how can we be absolutely certain that 2 triangles are perfect identical copies of each other?
This is precisely what the exam board is looking for. To prove 2 triangles are congruent, you can't just eyeball it. Nope, you have to use one of 4 very specific conditions. Let's run through them right now.
First up is SSS, which stands for side, side, side. And honestly, this one's as straightforward as it sounds. If you can show that all 3 sides of one triangle have the exact same length as the 3 matching sides of the other triangle, boom, you've proven they're congruent.
Second, we've got SAS. This means if you can show that 2 sides and the angle between them are equal, the triangles are congruent. And the key word there is between. The angle has to be literally sandwiched by the 2 sides for this rule to apply.
Third on our list is ASA. You've probably guessed it. If you've got 2 angles and the side that connects them being equal in both triangles, then they are congruent. Again, position is everything. It has to be the corresponding side sitting right between those 2 angles.
And finally, there's a special one that's just for right-angled triangles, RHS. This stands for right angle, hypotenuse, side. To use this, you've got to tick 3 boxes. Both triangles have a right angle, their longest sides, the hypotenuses, are equal, and one of the pair of corresponding sides are also the same length.
Okay, let's get a bit more practical. It's time to add the precision tools to our toolkit. For this section, you're going to need your pencil, a ruler, and a good old pair of compasses.
You are definitely expected to be able to do constructions like this one, and the key is precision. A perpendicular bisector has to cut the line exactly in half and at a perfect 90-degree angle. Oh, and here's the golden rule. Whatever you do, never ever rub out your construction arcs. The examiner needs to see you're working to give you the marks.
Now, these constructions are super important for solving loci problems. Don't let the word loci scare you. It's just a path of a point that follows a certain rule. For example, the locus of points that are always 2 centimeters away from a single point, well, that's just a circle. And the key fact to remember is that the shortest distance from a point to a line is always the perpendicular one.
All right, our 4th tool set is all about manipulating shapes. We're going to look at the 4 transformations, how to reflect, rotate, translate, and, the big one, enlarge shapes on a coordinate grid.
So here's a really crucial point. What's the difference between congruent and similar? Well, it's simple. If you reflect, rotate, or translate a shape, nothing about its size or shape changes. It's congruent. But the moment you enlarge it, the angles stay the same, but the side lengths change. That's what makes a shape similar.
For higher tier, you have got to be a master of enlargements. It's not just about making things bigger. A fractional scale factor actually makes the shape smaller. And a negative scale factor, well, that's where things get really interesting, because it flips the shape through the center of enlargement. You've got to practice those.
And that brings us to combined transformations. You'll often get questions asking you to do 2 transformations, one after the other, like a rotation and then a translation. My best advice? Just take it one step at a time. Do the first transformation, carefully track your coordinates, and then do the second one. Don't rush it.
Okay,
Let's wrap this up by adding the most advanced tools to our collection. We're talking about the topics where the real top-grade marks are hiding, starting with circles.
Now, to even begin to tackle circle problems, you've got to speak the language. You absolutely have to know your radius from your chord, your tangent from your arc. If any of these terms are a bit fuzzy, I'd seriously recommend pausing and making sure you know them inside out.
Okay, circle theorems. This is a classic exam topic, and it's what you can really show off and scoop up those top marks. The first big rule is this. The angle at the center of a circle is always double the angle at the circumference, provided they both come from the same arc.
Remember this one. Seriously, it's a lifesaver. If you draw a triangle inside a semicircle and one of its sides is the diameter, then the angle at the circumference will always be a right angle. It's a fantastic shortcut in so many problems.
So a tangent is a straight line that just kisses the edge of the circle. And where it touches, it will always form a perfect right angle with the radius at that exact point. Anytime you see a tangent in a diagram, you should be looking for that 90-degree angle. And here it is, our final tool, visualizing 3D shapes. You need to be comfortable with their properties, counting faces, edges, and vertices. But you also need to be able to draw plans and elevations. That just means drawing the 2D view from the front, from the side, and from looking straight down from above.
And there you have it. From basic angle facts all the way to circle theorems, your core geometry toolkit is now complete. You have the tools to deconstruct and solve pretty much any geometry question that comes your way. Now it's over to you. Go practice using them. Good luck.